Imagine a computer unlike any we've ever seen. A computer that harnesses the strangeness of quantum mechanics. A computer that uses holograms to store and process information. This is the promise of holographic quantum computing. It sounds like science fiction, but it is one of the most exciting frontiers in science today. We stand on the verge of a computing revolution. Our current computers, powerful as they are, have limits. They struggle with problems that involve vast amounts of data and complex interactions. Quantum computers offer a solution. They exploit the bizarre rules of quantum mechanics to perform calculations in ways classical computers can't. But even quantum computers face challenges. Building them is incredibly difficult. That's where holograms come in. Holography, the science of recording and reconstructing light, offers a new way to build and control quantum computers. This is the essence of holographic quantum computing, a fusion of quantum mechanics, holographic principles, and computational theories. It's a field bursting with potential, a field that could redefine the limits of human knowledge. To understand holographic quantum computing, we need to journey into the heart of matter itself. We need to explore the quantum realm, a place where the rules of classical physics break down. In this strange realm, particles can be in multiple states at once, a phenomenon known as superposition. They can also be linked across vast distances, their fates intertwined in a mysterious dance we call entanglement. These quantum phenomena are not just curiosities, they are the very essence of reality, and they hold the key to unlocking unprecedented computational power. Imagine a computer that can be in multiple states at the same time, exploring countless possibilities simultaneously. That's the potential of quantum superposition. Now, imagine these quantum states entangled across a vast network, sharing information instantaneously. This is the power of quantum entanglement. Holographic quantum computing seeks to harness these strange and wonderful phenomena. It's about using the fundamental building blocks of the universe to perform computations in ways we never thought possible. Let's delve deeper into the quantum world. Imagine a coin that can be both heads and tails at the same time. That's superposition. Now imagine two such coins linked so that if one lands on heads, the other instantly lands on tails, no matter how far apart they are. That's entanglement. These quantum properties are the foundation of holographic quantum computing. They allow us to move beyond the limitations of classical bits, which can only be 0 or 1. Quantum bits or qubits can be in a superposition of both 0 and 1 simultaneously. This allows quantum computers to explore a vast number of possibilities at once, giving them the potential to solve problems that are intractable for even the most powerful classical computers. Entanglement adds another layer of complexity and power. By entangling qubits, we can create complex correlations between them. This allows us to perform computations across the entire network of qubits simultaneously, further increasing the computational power. Now, let's bring holograms into the picture. Holography is more than just three-dimensional images. It's a way of encoding information in light itself. Imagine shining a laser beam through a special plate. This creates a three-dimensional image that appears to float in space. That's a hologram. The key is that holograms store information in a unique way. Every part of the hologram contains information about the whole image. This distributed nature of information storage makes holography a perfect match for quantum computing. In a holographic quantum computer, information wouldn't be stored in individual qubits, but rather in the relationships between them, encoded in the interplay of light and matter. This holographic approach offers several advantages. It could make quantum computers more stable and scalable. It could also pave the way for new forms of quantum computation based on the manipulation of light itself. Section 5. Unlocking Nature's Secrets. The potential applications of holographic quantum computing are staggering. Imagine simulating the behavior of molecules with perfect accuracy, atom by atom. This could revolutionize materials science, leading to the development of new drugs, super-efficient solar cells, and materials with unprecedented properties. Or consider the field of artificial intelligence. Holographic quantum computers could enable us to create AI systems with human-like intuition and learning capabilities, systems that can adapt and solve complex problems in real time. And let's not forget about fundamental physics. Holographic quantum computers could help us unravel the mysteries of the universe, from the behavior of black holes to the nature of dark matter and dark energy. These are just a few glimpses into the transformative potential of holographic quantum computing. It's a field that could reshape our understanding of the universe and our place within it. Section 6. A universe in a computer. One of the most intriguing possibilities of holographic quantum computing is its potential to simulate the universe itself. Imagine creating a virtual universe within a computer, a universe governed by the same laws of physics as our own. Such a simulation could help us answer some of the most fundamental questions about our existence. How did the universe begin? What is the nature of dark matter and dark energy? Are there other universes out there? Of course, building a universe-simulating computer is a daunting task. It would require unimaginable computational power and a deep understanding of the fundamental laws of physics. But holographic quantum computing could provide the key. By harnessing the power of quantum mechanics and holography, we might one day be able to hold the universe in the palm of our hands, a digital microcosm reflecting the grandeur and complexity of the cosmos. Section 7. Building the impossible. The path to holographic quantum computing is paved with challenges. Building these machines is pushing the boundaries of our technological capabilities. We need to trap and manipulate individual atoms, cool them down to near absolute zero, and control their quantum states with exquisite precision. And then there's the challenge of scaling up. To tackle real-world problems, we need to build holographic quantum computers with millions or even billions of qubits. This is a monumental engineering feat, requiring breakthroughs in materials science, laser technology, and quantum control. But the challenges are not insurmountable. Scientists and engineers around the world are making remarkable progress. New materials and fabrication techniques are emerging. Our understanding of quantum mechanics is deepening, and the dream of holographic quantum computing is drawing closer with every passing day. Section 8. The ethics of ultimate power. With great power comes great responsibility. As we venture further into the realm of holographic quantum computing, we must confront the ethical implications of this transformative technology. Imagine a computer capable of breaking the encryption that protects our most sensitive data, a computer that could crack the codes that safeguard our financial systems, our national security, our personal privacy. Or consider the implications for artificial intelligence. Holographic quantum computers could give rise to AI systems with cognitive abilities surpassing our own, systems that could challenge our understanding of consciousness and sentience. These are not scenarios to be taken lightly. We need to establish ethical guidelines for the development and deployment of holographic quantum computing, guidelines that ensure this powerful technology is used for the betterment of humanity. Section 9. A global effort for a quantum future. The pursuit of holographic quantum computing is not a solitary endeavor. It's a global effort requiring collaboration between scientists, engineers, ethicists, policymakers, and the public. We need to foster open dialogue and knowledge sharing across disciplines and national borders. We need to invest in education and outreach, inspiring the next generation of quantum pioneers. And we need to engage the public in a conversation about the potential benefits and risks of this transformative technology. Holographic quantum computing has the potential to reshape our world in profound ways. It's our collective responsibility to ensure this technology is developed and used responsibly, ethically, and for the benefit of all humankind. Section 10. The dawn of a new computing era. We stand at the dawn of a new computing era, an era defined by the marriage of quantum mechanics and holography. Holographic quantum computing has the potential to revolutionize fields from medicine and materials science to artificial intelligence and fundamental physics. It could unlock new frontiers of knowledge, solve some of humanity's most pressing challenges, and reshape our understanding of the universe and our place within it. The journey ahead will be challenging, but the rewards will be immeasurable. By embracing the spirit of collaboration, innovation, and ethical responsibility, we can unlock the transformative potential of holographic quantum computing and usher in a new era of scientific discovery and technological advancement. The future of computing is quantum. The future of quantum computing is holographic. The future is full of possibilities, and it's up to us to shape it wisely.